This tutorial shows how to calculate the effect size for observable main effects in a two-way ANOVA in SPSS. For the two-way ANOVA itself and the interaction effect, there are corresponding links to videos in the info cards and description below. Calculating the effect size for the pairwise comparisons of the interaction effect was relatively straightforward. It only required conducting independent t-tests. However, this does not work for the main effects, because the mean differences are calculated while accounting for the other main effect. This can be clearly seen here. In the descriptive statistics, the mean for men is 3,659 and for women 3,012. When the factor experience is considered, the values are slightly different, 3,641 for men and approximately 3,099 for women. An approximate method for calculating Cohen's d still exists, if you're willing to do a bit of math and derive it based on the formula for the t-value. In summary, I replaced the mean difference in Cohen's d formula and subsequently the t-value. The document is available on my homepage and is linked in the video description. For the calculation, I simply use Google Sheets and only need 4 values: the mean difference, the standard error of the mean difference, and the sample size of group 1 and 2. Using gender as an example, all relevant data can be found in the descriptive statistics and pairwise comparisons tables. The value 549.759 for the mean difference must be taken from the pairwise comparisons table, as well as the standard error of the mean difference 96.876. Only the group sizes are taken from the descriptive statistics table, 137 for men, 113 for women. The experience levels are ignored for this count. Plugging the values into the formula and calculating is fairly easy, and we obtain a Cohen's d of 0.72 for the difference between men and women. I'll get to the interpretation in a moment. For the second factor and its main effect, we have 4 levels, resulting in 6 pairwise comparisons. Let's take the difference between experience level 1 and 2 as an example. Note, I'm not using the word significant or comparing the p-value to an alpha level of 0.05. The focus here is on sufficiently small p-values in context. I recommend the paper by Wasserstein et al. On this, the link is also in the video description. In short, a difference between experience levels 1 and 2 can be observed. So, we use the mean difference of minus 357.588 and its standard error of 134.515. For the group sizes, all groups of the other factor for both experience levels must be added. In group 1, that's 31 men plus 29 women equals 60. In group 2, it's 28 plus 35, which is 63. The result is a d of approximately 0.48. The other pairwise comparisons with sufficiently small p-values can be conducted analogously. Finally, let's talk about interpreting the calculated effect sizes. First, you should check whether there are comparable studies that can serve as a reference for interpreting the observed effect sizes. In that context, it's particularly important to verify how those studies calculated Cohen's d. When reporting your own calculated effect size, it's crucial for transparency and replicability to clearly state how the calculation was done, and to emphasize that comparability to previous studies may be limited if those studies didn't specify their method. If no comparable studies exist, research field-specific thresholds for d can be used, but again, the method of calculation should be clearly stated. If there are no research field-specific thresholds, then the general thresholds from the social and behavioral sciences proposed by Cohen 92 can be referenced. 0.2, 0.5 and 0.8 for small, medium and large effects. Again, the calculation method should be mentioned for reasons of transparency and replicability. Once all calculations within the two-way ANOVA have been completed, the results must be reported. And that is what the next video will show.